and welcome Mindsetters to this session of Learn Extra Live. We're here doing the grade 12 session, Maths. I'm Ty and I'm here with Natasha who's going to be taking us for today's session. How are you doing?
Hi Ty, I'm great. How are you doing?
Good.
Good.
So what are we looking forward to today?
Okay, well, I know you grade 12s last week. We got a whole lot of requests for paper 2. Obviously everyone, well, not everyone, but some of you are writing paper 2 this week. So we're going to do a lot of paper 2 revision. So if you have questions, anything you're not sure about, as Ty will let you know, send them through.
Exactly. All right. So while you make your way across the board, Mindsetters, you know the drill. Get on the page, www.facebook.com/learn extra. Talk to me. Let me know what you guys are thinking. If you're lost anywhere, if you need help, as I always say, post. And I have this awesome Casio calculator to give away and this labeler. So please make my job easy and just keep posting on the page and we'll have those sent to you. And I just want to send a quick shout out to Liberty. Thank you for sponsoring the show. And this is where I then hand over to Natasha, who's going to take it over. Take it away.
All right, guys. So as I said, today we're going to do paper 2 because we've got so many requests and so many questions coming in for paper 2. And I know a lot of you are writing this week. So this is going to be good exam preparation for you. The questions we are doing today are coming from the November 2010 paper. So if you have that paper, if you've been working through it and you've got stuck anywhere, then you can obviously drop Ty notes as he said before. So let's get going. All right, the first thing we're going to look at is a question on analytical geometry. And before we tackle the question on analytical geometry, just a few things you need to remember. They do give you your gradient formula and your midpoint formula and the equation of the line and all of that on your formula sheet. But I just want to revise and go through some of those equations quickly. So remember, for your gradient of a straight line, the formula we use is y2 minus y1 all over x2 minus x1. Right, that's for the gradient. For your midpoint, remember the midpoint of a straight line is exactly midway between 2 points. So your midpoint of, let's just say, AB, that will be given by the x coordinate at point A, or we can say x1 plus x2 all over 2, and then y1 plus y2 all over 2. So still dealing with straight lines. The equation of a straight line is y is equal to mx plus c. Remember, m stands for your gradient, which you can work out using the gradient formula, which we started with at the beginning. C is your y-intercept. All right, another way for you to work out the equation of the straight line is using the alternate formula. Y minus y1 is equal to the gradient times x minus x1. In order to use this formula, you will need a point and your gradient. Okay, so that's just some of the formulae that we are going to be looking at when we tackle this question. Okay, so this is the first question, as I said, coming from the November 2010 paper. Let's have a look and see what it says. In the diagram below, A, B, and C are the vertices of a triangle. So A, B, C, vertices of a triangle. AC is extended to cut the x-axis at point D. All right, and you can see they give you the coordinates of A, B, C, but not of point D. The first question says, calculate the gradient of AD. Okay, guys, so remember that's why I showed you all those formulas at the beginning. If you want to work out the gradient, it's y2 minus y1 over x2 minus x1. The only point you've got to remember with gradients is that the order is very important. Okay, so if I'm going to start with the y coordinate of A, point A, then I'll need to start with the x coordinates at point A in my gradient formula. So let me show you what I mean. Okay, so this is number 5.1, and we're working out the gradient of AD. We know the formula is y2 minus y1 all over x2 minus x1. So you can choose, guys. You can either start from points, okay, well, if we look at the line firstly, they want the gradient of AD, okay, but we don't have the coordinates of point D. However, A, C, and D are points on the same straight line. So therefore, anywhere on that line, the gradients are the same. So the gradient from A to C will be equal to the gradient from C to D, which will be equal to the gradient of the whole line AD. So even though we don't have the coordinates of point D, we can use the coordinates of a point on the line to help us work out the gradient. So we're really finding the gradient of AC, which is exactly the same as the gradient of the whole line AD. Okay, so we're going to use the coordinates 3, 7 and minus 3, 4. So I'm going to start at point A, so I'm going to start with 7 minus the y coordinate at point C is 4. So it's going to be 7 minus 4 all over. And this is what I'm saying, guys. If you're going to start with the y value at point A, then your denominator needs to start with the x value at point A. All right, so then we're going to go 3 minus the x coordinate at point C. So it's going to be 3 minus 3. Okay, and that's going to give us 7 minus 4 is 3 over minus times a minus is a plus. 3 plus 3 is 6. So therefore that gradient is a half. All right, so we've done the first part. Let's look at the next part. They then want the gradient of BC. So let's have a look at your diagram. B is one of the vertices of the triangle, and in this case we do have the coordinates of both B and C. So you can either choose to start at point C and work out the gradient from C to B, or you can start at point B and then work out the gradient from B to C. Either way, it doesn't matter which one you start with first, as long as you keep the order correct, you'll get the same answer. Okay, so we're working gradient of BC, and we're going to go through this one a little bit quicker than the first one, because we know what the formula is. It's y2 minus y1 over x2 minus x1. So if I start at point B, I'm going to say minus 6 minus 4 all over 1 minus 3. Okay, so if we work that out, minus 6 minus 4 is going to give us minus 10 all over 1 minus times a minus is a plus, so it's going to give me 4 in the denominator. Minus 10 over 4 will simplify to minus 5 over 2. Okay, 2 goes into 10 5 times, 2 goes into 4 twice. So therefore the gradient of BC is minus 2.5. All right. Now that we've got the gradients of both BC and AD, the next question is actually linked to those gradients. Okay, and they often do this with analytical geometry. One of the following questions are usually linked to the previous ones. And this one, they want us to find the size of angle DCB. So how does the previous stuff help us? The size of angle DCB, which is this one. Okay. Now remember, when we're talking about angles and analytical geometry, we're using the angle of inclination. Remember that your angle of inclination is equal to tan of theta. So therefore, we can't work this angle DCB out directly, but using the gradients that we've just worked out, the gradient of AD, we could work out this angle here, which we'll call theta. Right? And then we've got the gradient of BC, so we can also work out this angle here, which we'll call alpha. Okay, so we can work out those two angles, alpha and theta. When we get those two, you can do quite a few things here. You can either do working out this part, which we call 180 minus alpha, and then do angles of a triangle to work out the angle DCB, or you could do exterior angle is equal to the sum of the interior opposites in your triangle. Okay, so whichever method you choose, as long as you follow through with your steps and don't make any careless mistakes, you should get the same answer. All right, so here we're working out angle DCB. And in order to do that, we've got to use angle of inclination. So remember, your angle of inclination is equal to tan of whatever angle you've got. So we'll say tan of theta. All right, so we're going to start first working the angle that the line AD makes with, and remember guys, whenever you're measuring angles, it's always in that, you might have wondered, why did I choose these to be my thetas and alphas? It's always measured in the direction of the x-axis. Okay, so that's how I know that the angle theta I'm working at is that angle CDM, and alpha also we're measuring in the direction of the x-axis. Okay, that's how we chose those. All right, so tan of theta, we're using the gradient of line AD. So to find my angle theta, I'm going to say tan of theta is equal to the gradient, which will give us an angle of inclination. And the gradient here of line AD is a half, so therefore if tan of theta is 0,5, you can use your calculator and work out the angle theta. Okay, so on your calculator, we're going to go, let's just bring this across. Okay, so we're working out the angle theta, so we're going to start by saying shift tan of the ratio, which is 0,5, equals. We get an answer of 26,565. All right, so that's 26,565. All right, and then the next thing we needed to work out was alpha, so we can say tan of alpha is going to be equal to the gradient of line BC, and the gradient of line BC, which we worked out before, was -5/2. All right, so therefore, working on your calculator, let's see what we get for alpha. All right, so here we're going to go shift once again because we're working out the angle, tan of negative. Okay, we're going to leave the negative out and I'll show you why just now. So we're going to go shift tan of 2,5, and our answer will be 68,198. Okay, so that's 68,198 and a few decimal places. Now guys, this angle, this is our, if you think back to your trig equations, this is your reference angle, okay? Because remember, your line here, this line BC is actually sloping, it's got a negative gradient, so it's sloping towards your negative numbers, it's sloping from left to right, okay? So therefore, the angle alpha is going to be an angle that's greater than 90 degrees because it's, you can see where it is here. That angle is going to be greater than 90 degrees. It's going to be an obtuse angle, all right? So the angle that we've worked out, that's 68. That's the angle on the inside, all right? Also, another way to think about it, remember from trig equations, if you're working with a negative ratio, you first work out your reference angle, and then we know that tan is negative in the second quadrant. So therefore, if I want alpha, it's going to be 180 minus the 68,198. Okay, so that's because we have a negative gradient for that line. So therefore, alpha is going to be 180 minus that answer, which gives us 111,801. Okay, so that's 111,801. Okay, so let's just go through that again. The angle that I'm working out, the alpha that I want is actually 111,801. The first angle we got, which was the 68,1, that's just our reference angle, and because the gradient is negative from trig equations, we know that tan in the second quadrant is going to be negative, so therefore we've got to say 180 minus to get the angle that we are interested in. Okay, all right, so now that we've got this angle alpha, to get angle DCB, we can use exterior angle of a triangle is equal to the sum of the interior opposite. So therefore I can say that alpha is going to be equal to theta plus DCB. Okay, and that's because of exterior angle of a triangle. But we know what alpha is and we know what theta is. The only unknown is DCB. So if I want angle DCB, I've got to say alpha, which is 111,81, minus theta, which we got as 26,565. Okay, so if we subtract that, so let's go down here again. So you see we've got that 26,565 is theta, we've got alpha as 111,801. If we subtract those two, we will get the answer for DCB. So it's 111 minus 26,565. And that gives us an answer of 85,2. Okay, so therefore angle DCB is going to be 85,2. Okay, so now that we've got that angle, we can move on to the next part, which says write down an equation for the straight line AD. Now guys, remember when you're trying to work out the equation, you need your gradient and you need your y-intercept. If you're using the formula y is equal to mx plus c, or you just need a point and your gradient. If you're using the other formula I showed you, which was this one, y minus y1 is equal to m times x minus x1. Okay, so we're going to use the second formula, this one here, to work out the equation of line AD. So on line AD, remember we don't have the coordinates of D, but we do have point C, which lies on the line AD, which helps us to work out the gradient. So we're going to use the coordinates of A, 3 and 7, and our gradient to work out the equation of the line. Okay, so this is now equation of AD. We know that in y minus y1, we have the coordinates of A with 3 and 7. So therefore, it's going to be y minus y1, which is going to be y minus 7 is equal to my gradient, which was a half, into x minus x1. All right, and we're just going to simplify that. So we're going to get y is equal to a half x minus 3 over 2. I've just times the a half into the bracket. We take the 7 across, so we get plus 7. And then we can add our numbers together, so we get a half x. And if we quickly find an LCD, it's going to be 2. So I'm going to get plus 11 over 2. All right, you can do that little fractional bit on your calculator, but 7 minus 3 over 2 will give you 11 over 2. You can rewrite this, and sometimes they might say write in the form, and then they'll give you, sort of an expression that you've got to match your answer to. So don't let that confuse you, because we can actually simplify this to write this, because you can see we have a common denominator of 2. We can times that 2 out, and we can write this as 2y is equal to x plus 11. Okay, so in some exams they might say show that the equation is equal to that. It's exactly the same process, we've just rewritten it. Okay, we still have more of this question to do, but Ty, you can tell me, do you want to take a break, or shall we just keep going with this question and finish it?
I think it's time for a break before their brains completely melt out of their ears. But on that note, mindsetters are key. I cannot stress enough. Make sure you get on the page so I can give this stuff away. We've got so much stock. Please post. But on that note, mindsetters, stay tuned. Do not go anywhere. We'll see you right after this break. Cheers. And welcome back, mindsetters. I just want to say my hat goes off. Well, not technically goes off, but my hat goes off to you for posting on the page and being active. Thank you so much, mindsetters. Keep on posting, keep talking to us. But on that note, this is where I hand over to Natasha. Natasha, take it away.
All right, guys. So just before the break, we were having a look at question 5 in the November 2010 paper 2. All right, we were looking at analytical geometry. We revised our formulae for straight lines. We looked at gradients. We looked at finding equations and angle of inclination. Now, the next part that we're going to look at is number 5.4, which asks us to find the coordinates of M, the midpoint of BC. All right, so you've got line BC, you've got the coordinates of B, you've got the coordinates of C, and they want you to find the midpoint M. So remember, once again, the formula for midpoint will be given on your formula sheet, but it's basically the sum of the x coordinates divided by 2 and then the sum of the y coordinates divided by 2. All right, so now we're working out, so this is the midpoints of BC. Okay, so the formula, so this is midpoint. It's going to be x1 plus x2. So if we have a look at our diagram, it's going to be minus 3, which is the x coordinate at point C, plus 1, which is the y coordinate, the x coordinates at point B, and then we're going to divide by 2. So that's going to be minus 3 plus 1 divided by 2 to give us the x coordinate of the midpoint of BC. And then to find the y coordinate, it's going to be 4 minus 6 divided by 2. All right, and that's going to give us minus 3 plus 1 is minus 2 divided by 2 is minus 1. And 4 minus 6 is minus 2 divided by 2 is also minus 1. So therefore the midpoints of BC is minus 1, minus 1. Now because they've given us a diagram, you can go up and actually see if it makes sense. And we can see that it does lie in the third quadrant. So the values x and y both have to be negative. So it sort of makes sense. Obviously, you know, taking into account silly mistakes and errors in that you may do addition wrong, but really you can sort of see if you're on the right track. Okay, if you get a positive answer in the third quadrant, you know you've made a mistake because both the x and the y values have to be negative. Okay, the last part of this question 5, they say if G is the point AB such that A, G, and M lie on the same straight line, show that B is equal to 2A plus 1. Now remember, if these points lie on the same straight line, so we're talking now, and I'm just going to draw it in here, we're talking about the points A, G, and M. Okay? Alright, I'm just going to go over that in case you guys can't see that. There we go. There's the points A, G, and M. So if they lie on the same straight line, it means that the gradients are always the same. So therefore the gradient from A to G will be the same as the gradient from G to M, which will be the same as the gradients of the whole line AM. Okay, remember, if they're all in the same straight line, they have to have the same gradient. So the gradient from A to G will be the same as the gradient from G to M, which will be the same as the gradient of the whole line. So therefore, if I have two of the points, which I do, I've got A and M, I will be able to find point G in terms of, remember here they're asking you to write B in terms of A. So we'll be able to use the gradients to help us write this in terms of A. All right, so the gradient of AM is exactly the same as the gradient from A to G, so you can choose whichever way you want to mix the formula up. It doesn't matter, you'll get to the same thing. So I'm going to say gradient from A to G is equal to the gradient from A to M. Okay, simply because the coordinates of A and M are known, so it'll make it easier to work out the values instead of ending up with A's and B's and the whole thing. So the coordinates of A are 3 and 7, and M was minus 1, minus 1. And I'm just going to write it down here so we don't have to keep on scrolling. So A is 3 and 7, and M was minus 1, minus 1. So therefore the gradient is going to be y2 minus y1 all over x2 minus x1. So that's going to give me 7 minus minus 1 is 8 all over 4. So therefore my gradient is 2. Okay, now if we take the coordinates of G, remember that was A, B, right? And I equate them, I say the gradient from G to M, or if you would like A to G, it's all going to be the same. So therefore, if I just work with the gradient from A to G, in terms of A's and B's, we can get the gradient as 7 minus B all over 3 minus A. Okay, guys, do you see what I've done? I've worked the gradient from A to G, and I'm saying I'm starting with 7 minus B all over 3 minus A. Okay, that gradient is going to be equivalent to the gradient of AM. All right, so I can now simplify this. I'm going to cross multiply. Remember, this is 2 over 1. So I'll get 7 minus B is equal to 2 times 3 minus A. So therefore, minus B is going to be equal to 6 minus 2A minus 7. And that's going to give me 6 minus 7 minus 1 minus 2A. Dividing both sides by -1, I'll get that B is equal to 2A plus 1. And if we go back to the question, we see that they actually asked us to show that B was equal to 2A plus 1. So we wrote B in terms of A. All right, so this is a typical analytical geometry question that you find in the beginning of your analytical geometry section. Remember this one coming from November 2010. Okay, and now I think it's time to move on to something that all of you guys love sending us questions on, and that's trigonometry. All right, Ty, are we still doing good there, or do we have any questions we need to go over before we carry on?
We're
Nothing
good for
on
now.
that first
More
one.
just requests of challenge question, please, please. But I'm like,
Okay, well, you can actually take this down as the challenge question, Ty. I don't know if you're going to be able to, but we'll give them this last question as the challenge question. I'm not sure what number it is in the exam paper. But guys, I'm putting the challenge question up basically now on the screen. So if you are watching, have a look, take it down. We've got to prove that for any angle A, 4 sine A cos A times cos 2A sine 15, all divided by sine 2A, and then open brackets, tan 225 minus 2 sine squared A. All right, and then you close your brackets. That's all equal to root 6 minus root 2, all divided by 2. Okay, guys, so this is your challenge question for those of you who have been asking for one. And you know what I like about this question is, and when we go through it a little bit later on, you'll see, it actually uses so many of the different sections that you've learned in trig. It uses a little bit of double angles, it uses compound angles, it uses a little bit of reduction. So if you're a little bit stuck, that's what you need to be looking at. Double angles, compound angles, and reduction formula to help you do this question. Okay. All right, so I think we're ready to go on to our next question for today, which comes from the same paper, question 9. Okay, also another typical exam question. If you go through any exams in the last few years, you're bound to see a question similar to this, where they say to you something like, in this case, given tan of alpha is equal to 3 over 4, they tell you that alpha is between 0 and 90, and they say with the use of a sketch and without using a calculator, calculate, and they give you a few things to calculate. So this is a typical exam question once again. All right, so they say without using a calculator, that's very important. So that means you cannot solve for alpha and then put answers for alpha in here. That you won't get any marks for that, none at all. Okay, so without using a calculator, no calculators allowed here to work out angles and that kind of thing. All right. So what sketch are they talking about? And I'm sure so many of you have seen this before. They've given us tan of alpha is equal to 3 over 4. They told you that alpha is in the first quadrant. So the diagram we can draw up is our Pythagoras triangle. So this is in the first quadrant. Okay, and I'm just going to make up a little axis here. And we've got something like that. Okay, so we've got a triangle in the first quadrant. Okay, alpha is between 0 and 90, so alpha is your angle there. they tell you that tan is 3/4, so tan is, remember, opposite over adjacent. So therefore, alpha is here, the opposites to alpha, the opposite side would be the y value, which is 3 opposite, and then your adjacent side would be 4. Okay, so this is the triangle we're going to use to help us to find sine alpha and all the rest of them. But the only way we're going to be able to use this triangle is if we have all the lengths. So how do we find the lengths of this? It's a 90-degree triangle in the first quadrant, so we can use Pythagoras. Okay, so if I want to work out the hypotenuse, I can say, well, I know in that triangle x squared plus y squared is equal to r squared. So therefore, I'm looking for r, which is the radius. I'll get 4 squared plus 3 squared is equal to r squared. So that's going to be 16 plus 9, which is 25. Okay, and you should all be very familiar with this 3, 4, 5 triangle. So therefore, your radius will be 5. Okay, the 3, 4, 5 triangle. There we go. All right, now that I have the hypotenuse, I can answer question 9.1, which says find sine of alpha. Well, we're just going to use the diagram that we've worked out. Remember, sine is opposites over hypotenuse, and I'm talking about angle alpha. So opposites is going to be 3, hypotenuse is 5. So therefore, sine of alpha is 3/5. Okay. The next one requires a little bit more working out. Here they say cos squared 90 minus alpha minus 1. Now guys, it's so important, and I keep reiterating, saying over and over again, that you need to know all of your grade 11 work for grade 12, and it comes up time and time again in trigonometry. You need to remember your co-functions. Cos of 90 minus is sine. Okay, so that's from your co-ratios, right? So cos of 90 minus alpha will just be, drop the CO off, oopsie, let's get that back up there, drop the CO and you'll be left with S. S stands for sine. Okay, so that's your co-ratio that we're going to be using. So now when they're telling us we need to find what cos squared 90 minus alpha is, they're really saying, well, you need to work out what sine squared alpha is minus 1, because cos of 90 minus is sine, and if we square that, we're going to get sine squared alpha minus 1. Okay, we've just shown you that sine of alpha was 3/5, so therefore I basically just put that in, substitute it in, and I end up with 9/25 minus 1. Okay, I just want to make sure that I've got my triangle right here. It's opposite over adjacent. Sine was opposite over hypotenuse, because obviously if you mess up your sides, you're going to get all your ratios wrong. So just while I'm checking, just a reminder for you guys as well, just go back and quickly, this is one of those things that you need to double check, because if you've messed up even one little side, one little ratio, all of the rest of them are just going to be, affected by that one thing. So I just wanted to double check that we had put the opposite in the right place and the adjacent in the right place. Okay, and we have. So therefore here our LCD is 25. If you want to, and I know most of you will have already reached out for your calculators, we can do it on the calculator. It's going to be 9/25 minus 1. And we get an answer of minus 16/25. Okay, so that part, yes, you can do on your calculator, because that was just working out the fractions. We didn't work out an angle or anything like that. Okay. All right, guys, so we're ready to do the last part of this question. Remember, the most important thing in this question was drawing the correct triangle, having all the right sides in the right places, and that helps us to work out the entire question. Okay, this question for 8 marks. Okay, and a typical exam question. So this one, 9.3, November 2010, 1 minus sine 2 alpha. Okay, so You all should recognize by now sine 2 alpha. It's going to need your double angle expansion. So sine of 2 alpha is 2 sine alpha cos alpha. All right. Once we've got it in that form, once we've expanded, we can just use the triangle that we've drawn. We know already that sine of alpha is 3/5. You want to work out cos alpha, you go back to the diagram. We know that cos is adjacent over hypotenuse, so it's going to be 4/5. So that's going to be 1 minus 2. 2 times 3 times 4, that's going to be 6 times 4, which is 24, all over 25. Again, the fractional parts you can do on your calculator, and you will get an answer of 1/25 as your final answer there. Okay, so I think this is a good point to take a break, let you guys grasp everything that we've done so far, Ty.
I think so too. So mindsetters, as I've been saying earlier, I just want to say thank you again for keeping on posting on the page. Do not stop, keep going. But for now, we're going to see you after this break. And welcome back, mindsetters. Hope you had a nice little break there. Took in a breath. Got yourself a snack, whatever you needed to now pay attention, you need to focus. We've got a lot to still cover. But make sure, guys, I cannot stress enough. Just get on the page, get chatting to me, let me know what you guys are thinking. Send those questions in. Because you do know you're writing in a couple of days, right? So this would be a good time to be asking questions. I don't know, I'm just saying. So, mindsetters, I cannot stress enough. Get your questions in so we can get those in at the end of the show. But for now, this is where I hand over to Natasha. Natasha, take it away.
All right. Okay, guys. So for some of you that didn't get the challenge question yet, I'm going to leave it on the screen before we actually tackle it. And take it down, see what you can do with it. As I said before, I really like this one because it covers quite a few sections, all right? While you're taking that down, I just want to remind you about some of the laws that we're going to use here. One of them being the double angle formula. Remember that sine of 2a is equal to 2 sine A cos A. All right, and also a concept that people get confused with quite a bit. Say I had sine of 4a, all right? So just from this formula, we can actually see what our results will be for sine of 4a, because remember, all you need to do is write 4a as a double angle. So I can write this as sine, all right, and I'm just going to get that question up again so you guys can take it down. So I can write it as sine 2 times 2a, because remember that 4a is 2 times 2a, and then I can expand that using my double angle to give me 2 sine, not a, but 2a, because now a double angle is 2a, and then cos 2a. All right, so it's the same formula, we've just manipulated it with a different angle. Okay, so that we will use a little bit later on when we tackle that question. Another formula that you guys need to remember, obviously all of your compound angles, but especially for this question, sine of A minus B. Okay, so using our compound expansion, this will be sine A, and we alternate, and it goes cos B. Keep the same sign in the middle, so it's a minus, and then we go cos A sine B. Okay, that's one of the other things we're going to use here. And then obviously you guys need to remember all of your reduction formulae. And then remember for cos of 2a, we have quite a few expansions to choose from. Well, we've got 3 to choose from. One of them being 1 minus 2 sine squared a. Okay, that's also equal to cos squared a minus sine squared a. Or we can say it's 2 cos squared a minus 1. Okay, so that's just some of the things we're going to be looking at when we look at this challenge question. Okay, remember guys, we are working from the November 2010 paper. Okay, so let's get started. Hopefully you all have the question down now. Okay, so we've got 4 sine A, and I'm just going to grab a hold of the question so I've got it in front of me. We've got 4 sine A cos A. I'm going to rewrite it at the bottom here. 4 sine A cos A times cos 2A times sine 15 all over sine 2A, and then in brackets we had tan 225 minus 2 sine squared A. Okay, and they've asked you to prove that this is equal to something. But remember, whenever you're dealing with an identity, you want to start with the side that has the most information, the side that you can manipulate the most. And in this case, the side with the most information and the side that we can work with a lot more is the left-hand side. Okay, so this is the left-hand side of the expression. Okay, the first thing we can do, all right, is we can see that we've got 4 sine A cos A. So we know that there's an expansion for sine of 2A, which is 2 sine A cos A. So if I could just get a 2 into that first expression, I could then use the expansion. Okay, remember your expansion formula, sine 2A is equal to 2 sine A cos A. So if you got 2 sine A cos A, you can actually go backwards, right? So I can rewrite 4 sine A cos A as, and I'm going to do this in as many steps as possible because it can get a little bit confusing. Okay, so I'm just looking at that first bit there. Okay, 4 sine A cos A. I'm going to rewrite that as 2 times 2 sine A cos A, and then you guys can see that 2, if I bracket that off, 2 sine A cos A is actually sine 2A. So this is equal to 2 sine of 2A. Okay, so I've just taken that little part of the sum to the side to show you how I can simplify that. Okay, so in place of 4 sine A cos A, I'm now going to put 2 sine 2A. So I've got 2 sine 2A cos 2A times sine 15. Okay, so just bringing that down as it is, all over sine 2A. Now guys, some of you might have spotted we've got 2 sine 2A cos 2A. Like I showed you in the beginning, we could rewrite that as sine 4A. Remember, I showed you this in the beginning. Sine 4A is 2 sine 2A cos 2A. However, in this question, if you are tempted to rewrite that as sine 4A, it actually becomes a little bit more tricky and you have to expand it out again anyway to get anywhere. So we're actually just going to leave it exactly as it is. So don't be tempted to rewrite that as sine 4A. Okay, but what we can see what's going to happen is we've got common terms. All right, we've got, let's just write this down first. We've got a common sine 2A in the numerator and the denominator. So therefore, we can cancel those out, right? When we cancel those out, we're left with 2 cos 2A times sine 15. Okay, now let's look at the denominator. I'm not putting that in just yet. I've got tan of 225 degrees. Now hopefully you all have been revising so much that you can just see straight away that this is going to be use of your reduction formula, or it's going to require use of your reduction formula. Tan of 225 we can rewrite as tan 180 plus 45 Okay, that's in the third quadrant where tan is positive anyway. So that's just going to stay as positive tan 45 degrees. Okay, so this is just an aside to show you what I'm doing with tan 225. So in place of tan 225, I can put in tan 45, but from special angles, tan 45, if you do on your calculator, is equal to 1. So we're simply going to replace tan of 225 degrees in the denominator with 1. Okay, so now my fraction becomes, once again, I'm just going to write in that 2 cos 2a times sine 15 all over 1 minus 2 sine squared a. Okay, so we just carried the second term through. All right, guys, remember one of the expansions for cos 2a, we did it right at the top, right in the beginning when we did a quick revision. One of the expansions for cos 2a is 1 minus 2 sine squared a. So I can now change the denominator to cos of 2a. All right. Therefore, what's going to happen, we've got, once again, a common term in the numerator and the denominator, so we can cancel them. So therefore, we'll be left with 2 sine 15. Okay, all right, so I hope you guys have been following. It's quite a lot of changing and chopping and changing we've had to do, but now that we've got to 2 sine 15, some of you might be tempted to say, well, sine 2 times 15 is sine 30, and somehow work around with a double angle. However, it's not going to work in the sum, okay, because we're missing a cos 15, so there's not really much we can do here. But we can't use double angles, but we can use the other thing that we learned in grade 12 trigonometry, which is called compound angles. So therefore, remember what we're trying to get to. We're trying to show that this whole thing is root 6 minus root 2 all over 2, right? So therefore, using my compound angles, I can rewrite 15 as 45 minus 30. Or you can write 15 as 60 minus 45. It doesn't matter which two special angles you use. Okay, I'm using 45 and 30. Then using my expansion for sine a minus b, this is going to become sine 45 cos 30 minus cos 45 sine 30. Okay, all right. Now we've got sine 45, cos 30, cos 45, sine 30. Those are special angles. You can work them out on your calculator. Okay, so if you do, you're going to get sine of 45 is 1 over root 2, or you guys will get root 2 over 2. It's exactly the same thing. Cos of 30 is root 3 over 2. Cos of 45, again, 1 over root 2 or root 2 over 2. It's the same thing. And then sine of 30, which is a half. Okay, I'm going to multiply the 2 into the denominator. So multiply each term by the 2. The first here, they're going to cancel. The numerator and the denominator is going to cancel. 2 and root 3 over 2, those 2's will cancel. So I'm going to end up with root 3 over root 2 from the first term. Multiply 2 into the second term. Once again, the 2 and the half will cancel. So I'm just going to get minus 1 over root 2. Both the denominators are root 2, so I can add the numerator, and I get root 3 minus 1 all over root 2. Okay, if you guys managed to get up to there, well done. Okay, you're really 90% of the way done. Yes, it doesn't look exactly like the answer, but if you've gotten this far, then it's really, really going to be just a quick manipulation of this to get to the answer that they want. Okay, so well done if you got this far. But now remember, we've got to manipulate that to make it look like what they want, which is root 6 minus root 2 over 2. Or guys, some of you will be able to take this and manipulate the right hand side to make it look like what we've got at the bottom there. Okay, but what I'm going to do is I'm going to work with our answer that we arrived at, and I'm going to make it look like the answer that they want. So how do we do that? We rationalize the denominator. How do we rationalize? That just means we need to get rid of the root 2 in the denominator. So the way we do that is we multiply by root 2 over root 2, because root 2 over root 2 is 1. So I've sort of introduced it in the sum, but I haven't changed the value of the expression because it's really multiplying by 1. So that will help us to get rid of the root 2 in the denominator. Root 2 times root 2 is the root of 4, which is just 2. And in the numerator, we're just going to multiply each term. So we're going to get root 3 times root 2, which is root 6, minus root 2 all over 2. And well done, we now have left-hand side equal to right-hand side. So we have proved the identity. So I hope that all of you guys were able to manage that challenge question, and I hope that you got to the answer. But if you didn't get to that answer, if you got up to root 3 minus 1 over root 2, I'm still very proud. All you need to do is rationalize your answer to get to the final thing. Okay, so I think it's about time we cross over to Ty to see if we have any questions.
Yes, okay. So, I've been scanning through the page, scanning. So, yes, we actually have a couple here. Basically, I think more of these just some of them mindsetters need just help working through them. So, Karabo, I think she wanted to find out sine 130 times tan 60 over cos 540 times tan 230 times sine 400, basically solving that one.
Okay, all right, so obviously we don't have time to do that entire question, but just some hints for you when you're doing that. Remember your grade 11 trigonometry, you need to go over that. That question just sounds like it's full of reduction formula. So you need to use your rules for reduction formula. Remember, when we're talking about reduction formula, you need to use your cos diagram. Remember the cos diagram? And you need to reduce your angles to special angles where you can. Remember, in the first quadrant, we use co-ratios. We use 90 minus theta. In the second quadrant, 180 minus theta. Remember, everything in the second quadrant is negative except for sine. And the third quadrant, it's 180 plus theta. And in the fourth quadrant, it's 360 minus. Okay, so you're going to use your cos diagram, remembering sine is positive in the second, tan in the third, cos in the fourth. Everything's positive in the first quadrant, but you need to remember your co-functions. And very, very important, when you do reduction formula, you're going to try to reduce everything to less than 90 degrees. You want them to be acute angles, and if they are special angles, then all the better. Okay, so I think that will help you quite a bit with that question.
All right. Let me see. I'm scanning to the page. I'm trying to see, because there was quite a couple, but the thing is, most of the mindsetters weren't really posting questions, as I was saying. They're more just posting answers, which is always a good sign, meaning that you guys are following along, which is brilliant, which means that you're understanding what's going on. And thank you guys for posting. Make sure you keep posting. And I cannot stress again, make sure that you tell a friend to tell another friend, to make sure that they tell a friend, to make sure that they tell a friend to get on the page and join us on the page. Make sure you keep on posting. Use the page. It's a forum for you guys, as I always say. And yes, I'll be scanning through to give out these Casio calculators and this labeler. I want to say thank you to Liberty for sponsoring the show. And wow.
And Ty, I want to say to everyone, good luck for the exam on Wednesday. Remember to work hard, study hard, and send us any questions if there are, and if we can help you, we will do. But yeah, otherwise, good luck for Wednesday. And
All
back
right.
to you.
Exactly what Natasha say. I say ditto. Good luck, everybody. Study hard, sleep before the exam, and tackle the question that you know the best. And this is where I sign off and say cheers and see you next time.